Hey, okay. I like this. Now it does show some tricks later on how to deal with some of these limits in an algebraic way. But I think you can still think of them just like you did in pre-calculus. It was all about the asymptotes and in behavior. And so on part A here, we've got this polynomial function that's going to end up having an x to the fourth. Now it's going to have an x to the fourth and then a whole, and other stuff too that you could find by doing the FOIL method. But the x to the fourth is the thing that really is going to dominate. So what I think of it then is it's the limit, and this is just my thoughts, which can work for you nicely on a multiple choice question. As I'm approaching infinity, I've got this x to the fourth, and then a bunch of stuff that's going to be lower than that. So plus, bop, 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 whatever. Okay. The most dominating factor, dominating thing in the entire problem will be that x to the fourth. So it's going to just drown out all this other stuff. I know there's some other things that will happen, and that's fine, except after a while, like a billion. If you put a billion to the fourth, that's going to dominate this question. Okay. And so this thing is just going to grow without bound. So that limit is infinity. It's just going to go forever and ever and ever. All right. Now, likewise over here, I'm substituting negative values in, right? And the most dominating thing on this one will be the x to the third. I mean, this stuff right here, just after a while, just is insignificant in comparison to this x cubed. Okay. So if I substitute very, very, very large negative values in here, well, that's going to be a very, very large negative value because you're cubing the negative, and cubing the negative is going to be negative. So this one is going to go to negative infinity. All right. So it's not only what you're substituting, what you are substituting into, but which side you're approaching. Okay. You really have to pay close attention to, am I going left or right? And then what is the behavior of this particular thing? Now, in Algebra 2 and pre-cal, you talked about in behavior, things falling and rising and all that stuff to the left and right. And that's kind of what we're talking about here. All right. Now, also, in Algebra 2 and pre-calculus, I want to think of this the exact same way we just talked about those previous ones. What's going to dominate here? Well, the x squares. So the x squares are your highest power. So these things right here really don't come into play. It's almost like you can ignore them. And so if I were to ignore them, because as x gets very, very large, then these things are the only things that really matter. And when I divide them, guess what you get? 3. All right. Now it's going to. There is a note about, and I'll write it. If the degree of the numerator and the denominator, there's a rule. If the degree of the numerator and denominator are equal to each other, then you divide. So just divide those leading coefficients. All right. So I can write that, no problem, and I will right here. So degree of the numerator, in this case 2, is equal to degree of every time. All right. So if that's true, then if those two are equal to each other, so let me change this to if the degree of the denominator is equal to the degree of the denominator, then the limit will be divide the leading coefficients. That's such a mess. 2 F's. Okay. All right. Good. So that's the rule. That's the rule. So, but like I said, you can kind of ignore everything but those highest powers as you go. Okay. All right. Now on the next one, if I do that again, well, what's going to happen is your as this gets larger and larger and larger, this is the most dominating thing in the entire quotient. And so as it gets larger and larger and larger, this fraction becomes closer and closer to zero. It never will be zero, but it gets closer and closer to zero. Now, so it doesn't matter from above or below. This one would actually, as you're traveling to the left, you'll have negative values. This would be a negative over a positive. So what's going to happen is, if I were to look at this graph, as you're traveling to the left, it's going to approach zero from below. So here's the graph's going to go. I don't know what it does before that, but it's just going to head like this. Okay. And so though it's negative, I'm still approaching zero because the degree of the denominator is greater. All right. So that's always going to be the case. So that's going to be zero. And again, we can write a little rule there if you want. It's the same rule that you had back in those two previous classes. Okay. So if the degree of the numerator is less than, try again, is less than the degree of the denominator, then the limit is to zero. Now, of course, these are limits as you're approaching infinity or negative infinity. And so on this one, it would not matter. The negative or positive aspect of that will just determine if it's going to approach a zero from above or below. And in this case, it's approaching it from below. And you can take a look at the graph and see that that's true. But that's the case. So on these, any polynomial is going to go to infinity or negative infinity, depending on exponents, depending on the situation. And then if you have a fraction, then if your if your degrees are the same, you will divide leading coefficients. And if you have a higher power on the bottom, it's going to approach zero from above or below. Okay, so that's all for that one.